Hello children, we have discussed about the tangent properties. When tangents are drawn from an exterior point to the circle, the length of the tangents are equal. Length means the length between from the exterior point to the point of contact, that is PA is equal to PB. This we have studied. We have completed up to question number 17 also, involving direct common tangent and transverse common tangent. So, a quick review. See here, when tangents are drawn, we have studied lengths are equal, then these two angles will be 90 degree. Why? Angle between radius and tangent is 90 degree, correct? And if you will see, this is a quadrilateral. Which one? P, A, O, B is a quadrilateral, correct? It means whenever we will draw two tangents from an exterior point, then after joining the point of contact to the center, always we will get a quadrilateral. The condition is whenever we will draw two tangents from an exterior point to the circle, and if we will join the point of contact to the center, then we have a quadrilateral. Why? 1, 2, 3, 4 sides. It means if in the questions this kind of condition is coming, where two tangents are drawn from an exterior point, first thing. Second thing, if point of contacts are joined to center, then we are getting a quadrilateral. And in this kind of quadrilateral, two angles must be 90 degree. Why? Since we are joining point of contact to center, it means OA and OB are radii, and angle between radius and tangent is 90 degree. Correct? Now in this quadrilateral OAPB, two angles are 90 each. It means sum of two angles is 180 degree. It means how many angles are left? Two angles. And what is the sum left? 180. Why? Total sum is 360. Two angles are 90 degree each. It means sum of two angles is 180. And how many angles are left? These two angles are left. It means what is the sum of these two angles? 180 degree. Why? 90, 90, 180. Two angles are giving sum 180. It means remaining two must give 180 also. Why? Total sum must be 360 degree. So this property we will use. What? When tangents are drawn from an exterior point, if point of contacts are joined to the center, then these two angles will be 90 degree, where tangent and radius are meeting at the point of contact, and remaining two angles will give some 180 degree. It means if this angle is given, we can find the angle between the tangents. This is the angle between the tangents. And if this angle is given, we can find this angle. This angle means the angle between the two radii. Which two radii? The radii which are joined to the point of contact. Clear? It means suppose this angle is given 110, then directly we can say that this angle will be 70 degree, using the properties of pair of tangents drawn from the exterior point. So we have to identify the diagram in which two tangents are drawn from exterior point of contacts are joined to the center, then we will get a quadrilateral. In that quadrilateral, these two angles will be 90 degree each. Y angle between radius and tangent. And then if these two will be 90, 90, it means two angles are giving sum 90 degree. Remaining two must give the sum 180 degree. Why? Total sum must be 360 degree. Correct? So we will use this property. And one theorem is left. The last theorem, angles in alternate segment. Why? Two theorems have been removed. Clear? So next question is based on what we have just reviewed or studied. So here in this diagram, from exterior point P, two tangents are drawn, PA and PB. Point of contacts are A and B. And you can see point of contacts are joined to center O. It means we are getting a quadrilateral PAOB, in which these two angles will be 90 degree by angle between radius and tangent. Just now we have studied. So in this quadrilateral PAOB, two angles are 90 degree each. It means sum of remaining two angles will be 180 degree. Means this angle and this angle will give some 180 degree. That is, these two are supplementary. Correct? Just now we have studied. So if this is 70 degree, this angle will be 110 degree. Correct? So what we will write? We will write PAOB is a quadrilateral in which angle PAO is equal to angle PBO is equal to 90 degree. The reason is angle between radius and tangent. So therefore angle APB plus angle AOB is equal to 180 degree by total sum is 360 degree. For a quadrilateral, sum of all angles 360 degree. Two angles, what is the sum? 180. It means remaining two will be 180. Therefore angle AOB will be 180 minus 70, that is 110. This angle is already given 70 degree. Correct? So first part. Now we have to find AQB. Where is you see these two angles are subtended by same arc AB. By same arc ABC, A and B are joined to center O. A and B are joined to point Q on the circumference. It means both angles are subtended by same arc AB, one at center, one at circumference. So circumference will be half of the center. It means we can write angle AQB is equal to half of angle AOB. Right? The reason is angle subtended by the same arc AB, one at center, one at circumference. Correct? We have done this kind of question. So angle AQB will be half of 110, that is 55 degree. Correct? So this angle is 55 degree. Third part, we have to find ARB. Very easy. See, what is the type of quadrilateral AQBR in the diagram? What is the type of quadrilateral AQBR? AQBR is a cyclic quadrilateral or not? Why? All the 4 points are on the circumference and joined to form a quadrilateral, and sum of opposite angles of a cyclic quadrilateral is supplementary. It means directly you can write ARB or ARB plus AQB is equal to 180 degree. Correct? So we can write angle ARB is equal to 180 degree minus. This already we have calculated what? 55 degree. It means answer will be 125. Correct? This is the question. Next. So next theorem, that is the last theorem of the chapter, angles in alternate segments. Angles in alternate segments are equal. So how to understand the theorem? We will proceed from the last word, segment. What are the segments in the circle? Segments are formed when we draw a chord in a circle. Segments are formed when we draw a chord in a circle. A chord divides the circle in two regions and each region is called a segment. If the segment is bigger than semicircle, the segment is called major segment. If the segment is smaller than semicircle, the segment is called minor segment. Correct? So how to understand this? See, for this theorem we require two things. One is a tangent. One thing we require a tangent. Clear? Then from the point of the contact, we have to draw or identify a chord, any chord. First a tangent, then from point of contact we require a chord. Suppose I am drawing the chord. Suppose this I have drawn the chord, and the chord is PQ. Correct? So two things are required for this theorem. One tangent, and on the tangent we are interested in the point of contact. So APB is a tangent, P is point of contact. From the point P you have to draw a chord. in any direction. So I have drawn the chord PQ. So whenever you will draw a chord in a circle, the chord will divide the circle in two regions. One is this region, another one is the smaller region. These two are the segments. Alternate segments means for this segment, the smaller one is alternate. For this segment, the smaller one is alternate. That is why angles in alternate segments. If the two angles are in alternate segments, both are equal. But how to identify the angle C? One angle is between the tangent and the chord. Tangent is there. On the tangent, we will take the point of contact. From the point of contact, we have to draw a chord, correct? So one angle is between the chord and between the tangent, maybe on this side or maybe on this side. We are having two angles. We have to take angle between tangent and chord, maybe this side, that is APQ. Another side we can take also angle between tangent and chord, that is BPQ. So first I am taking one angle, suppose this side. Correct? I am taking on this side. Then we have to join the end points of the chord to any point in the remaining part of the circle. See, this is the chord PQ. We have to take any point in the another segment, in the alternate segment. It means suppose I have taken one point here, that is R. Correct? Not here we have to take. We have to take any point in the next segment, in the alternate segment. And then you have to join R to the end points of the chord. Correct? Clear? First step, a tangent. From the point of contact, we have to draw a chord. So I have drawn the chord first, PQ. Then we have to take a point, suppose it is R, in the remaining part of the circle. It means in the next segment, that is R. So here what is the angle subtended by this point? This. Then these two angles will be same. If this is X, this will be also X. So these two angles are called angles in alternate segment. Here, see it properly. First of all, I have drawn one tangent, that is BPA. Then on the tangent, you have to take point of contact, that is P. From the point of contact, you will draw a chord, any chord in any direction. I have drawn PQ. Then end points of PQ must be joined. End points of PQ must be joined to any point in another segment, that is alternate segment. So I have taken R. When R is joined, we have one angle PRQ. So these two angles will be equal. Which two angles? Angle APQ. Angle APQ is equal to angle PRQ. These two angles are called angles in alternate segments. Now why these are called angles in alternate segment? One is in minor segment, another one is in major segment. Though it is not completely in the minor segment. Why? Minor segment is up to here, but we have to take the angle between the tangent and the chord. So this angle is more in smaller segment, that is this segment, minor segment, and remaining angle will be, the next angle will be in the major segment. First angle will be between tangent and chord. Second angle will be between the chords. Clear? So I have taken that part. If I will take this part, then suppose I have to take this angle. So once again I am coming to the beginning. What was the beginning? We have a tangent. From point of contact, I have drawn one chord. This time I will take this angle. This angle is also the angle between tangent and chord or not? Between tangent and chord. It means angle is angle BPQ. Correct? We have to take the angle between tangent and chord. Then we have to take any other point in the next segment. See, this segment is occupied. It means we will take another point in next segment. That is Suppose the chord is this. Correct. Suppose the chord is this, then the angle will be this. Correct. BPQ. So we have taken the angle between tangent and chord. Chord is drawn. So we have to take another point in another segment. This segment is occupied. It means in this segment we have to take any point, but on the circle. So I have taken here, suppose this is S, any point on the circumference. Then we have to join end points of the chord to this point. Correct, I have told? We have to join the end points of the chord to this point. So what is the angle between the chords? This. It means both will be same. That is, angle between tangent and chord is angle BPQ is equal to angle between the chords, angle PSQ. Again, these two angles are angles in alternate segment. Now understood? Here, tangent is drawn from the point of contact. We have to identify one chord. Then, first angle will be between tangent and chord in one segment. Next angle, how to identify? You will take the end points of the chord and identify or find any one point which is on the circumference, but in the next segment, in the alternate segment. Now here you can see P and Q are joined to point S on the circumference and in the alternate segment. It means both angle will be same, and the name is angles in alternate segment. Understood? This we are going to use in the next question number 21, both the parts. Understood? So the question. Next question 21, first part. What is given? BD is diameter of the circle. PAQ is tangent at the point A of the circle. Two angles are given. Angle ADB 30 degree, angle DBC 60 degree. Correct? We have to find three parts. QAB angle between tangent and the chord AB. PAD again angle between tangent and chord AD, and angle CDB. Why CDB is asked? It is very CDB. CDB is asked. Okay, CDB. So next, first, if BD is diameter, we can use angle in semicircle. If BD is diameter, you can see end points of the diameter are joined to 2 points on the circumference. Then this will be 90 degree, this will be 90 degree. Correct? Clear? So, BD is diameter. BD is diameter. Therefore, angle BAD is equal to angle BCD is equal to 90 degree angle in semicircle. Correct? So if this is 90, this is 30, this will be 60 degree. Similarly, this is 90, this is 60, this will be 30 degree. Correct? 30, 60, 60, 30. Understood? So first part you have to find angle QAB. See, this angle QAB is the angle between tangent and chord AB. Correct? See, I am going to apply angles in alternate segments. See, first of all, tangent is there. We want angle between tangent and chord. Chord is B. So this angle is angle between tangent and chord. One angle we have obtained related to the theorem angles in alternate segments. Second angle will be obtained by joining the end points of A and B to any point on the circumference. Now you see, end points of A and B are joined to any point on the circumference. Which point? That is D. So what is the angle formed by AB at D? That is ADB. That is which angle? This angle. AD. It means these two angles will be same. Using the theorem angles in alternate segment. Why? We want a chord from point of contact. Point of contact is A. So chord is AB. One angle between tangent and chord is angle QAB. Next angle must be obtained by joining the end points of the chord, that is AB, to any point on the circumference, and on the circumference it is D, and C, A and B are joined to any point on the circumference, that is D. It means this angle will be equal to angle ADB and the value is 30 degree. Correct? This is why angles in alternate segments. Correct? It means this angle will be also 30 degree. Clear? Slowly we will understand. So first part, the second part we have to find PAD. Again, we are going to apply the same. See, that was done. Next, again see, PAD means again the angle is between tangent and chord. See, tangent P A Q and the chord. This time the chord is AD. So what is the angle between tangent and chord? And you can see the chord is drawn from the point of contact. So one angle is angle PAD, angle between tangent and chord. Once again I am saying, second angle will be joined or obtained after joining the end points of A and D to any point on the circumference. Can you tell me, or you can identify whether A and D are joined to any point on the circumference? See the diagram properly. First angle, angle between tangent and chord, that is PAD. Of the angles in alternate segment theorem, we require two angles. One angle obtained. Second angle must be obtained by joining the end points of the chord to any point on the circumference. You can see A and D are joined to any point, that is B. It means this angle. Which angle? This angle. It means these two angles will be same using the theorem angles in alternate segment. Why? One angle between tangent and chord, and that chord again we have to take end points of the chord must be joined to any point on the circumference in another segment. One segment is this, another segment is this. It means these two angles are again angles in alternate segment. This is already we have calculated 60 degree, therefore this will be also 60 degree. It means angle PAD is equal to angle ADB is equal to 60 degree. See, now from the letter also you can identify. How you will verify? Two letters must be same. See, PAD and ADB, and AD must be, A and D means one point will be point of contact, another point will be end point, and the third point will be also end point, that is on the circumference. So these two angles are in alternate segment. CDB already we have calculated, correct? 90, 60, then CDB will be 30 degree. Clear? Next. Next question, 21B part. What is the question? We have to find the angle CAB. CAB. It means this angle we have to find. What is given? ABCD is a cyclic quadrilateral. The tangent to the circle at B meets DC produced at F. Angle EAB 85 degree. Angle EAB 85 degree and angle BFC. Angle BFC is 50 degree. Find CAB. So first of all, what is 85 degree? If you will see, ABCD is a cyclic quadrilateral. ABCD is a cyclic quadrilateral. And for this cyclic quadrilateral, two sides are produced. DC is produced to F and DA is produced to E. So whenever sides are produced, whether in a triangle or a quadrilateral, we will get exterior angle. So here which exterior angle is given? 85 degree. So you can see properly angle EAB is exterior angle for cyclic quadrilateral ABCD, correct? EAB, correct diagram? EAB. So EAB is exterior angle for this cyclic quadrilateral, and exterior angle of cyclic quadrilateral is equal to its interior opposite angle. It means angle EAB is equal to angle BCD is equal to 85 degree, correct? Exterior angle property of cyclic quadrilateral. Exterior angle will be equal to its interior opposite angle. It means this angle is 85 degree. Again, you can see in the diagram, for the triangle BCF, you can see FC is produced. Why? BCF is a straight line. It means we can say angle BCD is exterior angle for triangle BCF or not, correct? Visible? Yes. Angle BCD is exterior angle for triangle BCF, and for the triangle exterior angle is equal to sum of its two interior opposite angle. It means 55 degree will be equal to 50 degree plus angle CB. Exterior is equal to sum of its two interior opposite. It means 85 degree is equal to 50 degree plus CBF. Suppose this angle is X. So we can find X. X will be 35 degree, correct? X is 35 degree. So we have calculated angle CBF. Now next, we have to calculate finally angle CAB in the question. So we have calculated X. Now we are going to use angles in alternate segments. See how to use. First, remove all these angles. And this will be better. This also, we are knowing all the values. So, you can see the tangent is BF. The tangent is BF and the chord is BC. The chord is BC. So, one angle is between tangent and chord, that is angle CBF, correct? One angle between tangent and chord. Tangent is BF, point of contact is B, and from B chord is drawn, that is BC. Then we have to join the end points of the chord to any point on the circumference. To any point on the circumference. Now you will identify, you will search. End points of the chords are B and C, and you can see B and C are joined to only one point, that is A. So the next second angle is this. It means these two angles will be angles in alternate segment. One angle between tangent BF and the chord from the point of contact, that is BC. Then we must have to find one point in the remaining part of the circle in next segment from where the end points are joined. You can see B and C both are joined to one point, that is A. So these two angles are angles in alternate segment, correct? That is angle CBF is equal to angle CAB, correct? And this angle already we have calculated. This angle is what? We have calculated 35 degree. It means this will be equal to 35 degree. That is angle CAB is 35 degree. Correct? In this question, we can take another chord also. What? AB chord is also a chord joined or drawn from the point of contact. But if you will take the AB chord, the corresponding angle in next segment will be C. A and B are joined to which point? On the circumference, that is C. It means these two angles will be angles in alternate segment. But nothing is asked about this point. That is why we have taken which chord? The chord BC. Tangent is BF and the chord is BC from the point of contact B. Angle between tangent and chord is CBF. That will be equal to the angle obtained by joining the end points to any point that is remaining part of the circle at the circumference, that is angle CAB, that is 35 degree. Correct? Thank you.